Pluto, once part of our solar family, is presently a far-off, dim dwarf planet that has drifted out of the spotlight until now. Surprising new assertions from well-known space experts like Neil deGrasse Tyson have brought Pluto back into the spotlight, along with Michio Kaku. They've suggested that it's possible this small, icy world is actually moving in a direction that could be dangerous, staking it straight into Neptune. And this isn't just a random thought they're sounding the alarm. They believe Pluto could be heading directly for a massive, destructive collision with Neptune. But how could that even be? And what would actually happen if, in fact, two planets collided with one another? Are some simply misleading us? Is it an unusual space illusion, or are real and terrifying events taking place? Pluto's path through space puts it dangerously close to Neptune. Tyson and Kaku are releasing grave warnings. Even the slightest change in Pluto's orbit could set the stage for a catastrophic event that might one day threaten Earth. Perhaps the most pressing concern is how a situation like this could even occur. Join us as we examine what a possible Pluto-Neptune collision could really mean. Despite the fact that Pluto lost its planet status and was reclassified as a dwarf planet, it still holds scientific and public curiosity, with top scientists now pointing out that its orbit moves dangerously close to Neptune's. Tyson's curiosity has evolved into concern. Both Tyson and Kaku, well-known figures in the world of astrophysics, have raised red flags. A potential serious issue, they claim, is that this alignment may not be merely a passing blip, but could hold actual threats for Earth. But how exactly would something like this work? The way Pluto circles our sun is anything but typical. Unlike most other planets, it takes Pluto about 248 Earth years to make a complete turn around the sun. Since we discovered it in 1930, it hasn't even completed a full orbit. Nonetheless, the method by which Pluto follows its orbit is unusual. It's not round like the other planets. Rather, it's stretched out and tilted away from the usual planetary patterns. Pluto's orbit has a 17. It's tilt in comparison to all of the other planets. And here's the strange part. For about 20 years in each cycle, Pluto actually travels closer to the sun than Neptune does. That's right, despite the fact that it is technically farther out. Pluto dips inside Neptune's orbit for decades at a time. So the obvious question is, why haven't they crashed? The solution lies in the delicate gravitational dance of the solar system. After Pluto was first discovered, astronomers immediately began attempting to determine how it fits into the solar structure. The majority of planets remain roughly aligned within the solar system's flat disk, but Pluto moves according to its own rhythm with a sharp tilt and a path that's not straight. It crosses into Neptune's domain. Yet somehow it hasn't collided. This is where cosmic mechanics come into play. There's something known as the three-body problem, where researchers try to comprehend how three massive space objects like Pluto, Neptune, and the Sun pull on one another. Predicting this interaction is like trying to map a complicated dance where each partner pulls the others in different directions. For Pluto, this puzzle involves some odd but important ideas, like asynchronous oscillation, orbital drift, and something referred to as the VZK wobble. These all help explain why Pluto hasn't crashed into Neptune. Let's break them down. Asynchronous oscillation occurs when Pluto travels along Neptune's path, but is always at least 90 degrees away from it, like two dancers always on opposite sides of a circle. This separation prevents collisions. Orbital drift means Pluto's path moves vertically up and down in comparison to the flat paths of other planets. So, even when it's closest to Neptune, it may actually be far above or below the orbit again, avoiding disaster. The VZK wobble, named after researchers Zell, Kai, and Kaku, examines how the Sun, Pluto, and Neptune each pull on the others. These gravitational pulls aren't random. They create a kind of rhythm, long-term equilibrium that keeps Pluto's path steady, even if it looks wobbly or strange. This wobble shows that space, while it may appear wild and unpredictable, is underpinned by order. Cosmic patterns help keep Pluto on track, prevent it from colliding with Neptune, and maintain harmony in the solar system. This interaction between three celestial bodies is crucial too. understanding how orbits function and shift under the pressure of massive gravitational forces. It also helps scientists understand how Pluto's orbit might behave in distant star systems. In the 1980s, computer scientists ran complex simulations and found something amazing. Even though Pluto's orbit is protected and stabilized by a few features, it is still unstable over very long periods of time. Minuscule shifts in Pluto's position or speed could lead to massive differences in where it reaches hundreds of years later. Nonetheless, this fragile balance has remained for billions of years. Pluto's orbit is like a tightrope delicate, but capable of staying upright across a cosmic chasm. Modern astronomers, aided by automated tools, have observed how massive planets such as Neptune, Saturn, and Jupiter influence Pluto's orbit. Interestingly, Pluto and Neptune have a kind of orbital alliance. For every 2 laps Pluto makes around the Sun, Neptune makes 3. This 2 to 3 resonance acts as natural protection, keeping Pluto out of harm's way. But Neptune isn't the only protector. Jupiter's massive gravitational force plays a significant role in keeping Pluto safe. Saturn adds to this influence as well. Jupiter's mass is so great that it can help hold Pluto in a stable path for incredible lengths of time. Together, these 3 giants act like guardians, ensuring Pluto stays safely in its lane. These bizarre but crucial orbital patterns help keep our solar system from becoming a disorganized mess. Without them, space would be filled with crashes and ejections. As objects struck each other or were flung out into the void, Pluto is a great example of how understanding motion in space helps us avoid major disasters. Watching how Pluto moves enables us to comprehend the larger mechanics of our cosmos. Pluto's system and the constant changes it brings, its strange orbit, show us that even a path that looks unstable can find balance. Thanks to the invisible forces of gravity and motion, it also shows why keeping an eye on odd things is so important. They have a lot to teach us about how the universe works. Deep research into space's corners serves as a reminder of how bizarre our cosmos is. Pluto is a fascinating aspect of our universe, an excellent illustration of the kind of strangeness that scientists call orbital chaos. This means that a planet's path can change dramatically depending on where it is, starts, and how it moves. Even the tiniest changes to where Pluto started can result in totally distinct outcomes in the future. That's where computers come in. They allow researchers to experiment. What would happen if they made small changes to Pluto's speed or location? Simulations have shown that even though Pluto can use some stabilizers, even if it starts out on the right path, just a little differently, its unpredictability has persisted. Yet despite this, it has stayed on a regular course for billions of years, which indicates that while it may wobble, it's still locked into a larger rhythm. Trying to figure out where Pluto will continue for a very long time. Extremely difficult, as systems like this are so sensitive to small changes. Even the best mathematical models have limits. They rely on getting the starting numbers right. A small error or unexpected event can throw everything off, but Pluto perseveres. Despite these challenges, it offers valuable lessons. It shows that the solar system is constantly changing. Our comprehension of it is ever growing, and even the planets we thought we knew can surprise us. So why now are experts like Michio Kaku and Neil deGrasse Tyson warning about a potential collision between Pluto and Neptune? Aren't there enough safety nets in place? Neil deGrasse Tyson, one of the most popular science communicators, has a special point of view on Pluto. He famously played a role in transforming it from a planet to a dwarf planet. He didn't insult Pluto by doing this, but rather reflected our improved comprehension. For him, Pluto is a representation of how science develops and evolves. Tyson sees Pluto's strange orbit as a reminder of just how much we don't know and how that mystery keeps astronomy exciting. However, when it comes to Pluto's path, Tyson is not entirely confident. He's worried. He admits that although Pluto's orbit has stayed safe so far, incremental changes over time could result in catastrophe. Neptune and Pluto's paths currently create an intricate pattern that avoids collision. 8. But Tyson believes a small push from an additional object, or a shift in gravitational forces, might be sufficient to veer Pluto off course. If those modifications accumulate over thousands or millions of years, the outcome may be total chaos. Even in the event of a collision, this wouldn't happen tomorrow, or even in our lifetime. It would take an incredible amount of time.
However,
Tyson maintains that we should pay close attention to Pluto's path. He believes it requires ongoing research. And not only is Tyson concerned, Michio Kaku, an outstanding theoretical physicist, also recognizes the possibility of danger in space. He admires the same things as Tyson does, the splendor and awe of the universe. But he likewise warns that planetary routes are always on the edge of change. Both Kaku and Tyson agree that we need to keep exploring space and tracking these invisible forces that shape our solar system. Pluto's situation is a powerful illustration of how space is always changing. Each new discovery raises more questions as science advances. The albeit small probability of a collision between Pluto and Neptune highlights the fact that the universe is never completely foreseeable. Even in its quietest corners, space can hold surprises. We are encouraged by Pluto's story to remain eager to continue observing the skies and to remember that the cosmos still holds numerous mysteries waiting to be discovered. Now, for a moment, imagine that despite everything, Pluto does achieve the impossible. All of the safety nets, created by gravity and stable patterns, occasionally deviate from their delicate track. Maybe a rogue asteroid zips by and nudges it just a little. Or perhaps the slow but constant tug of a second distant object accumulates over time. What then? If Pluto were to leave its secure orbital rhythm and begin to drift toward Neptune, even a single collision on the cosmic timescale could occur after thousands or millions of years. But even so, the consequences could be staggering. Astronomers would first notice subtle changes, Pluto reaching specific points a little earlier or later in its orbit than expected. Over decades, those shifts would add up. And then one day, it could be directly in the path of collision. When two space collisions involve large objects, especially those with a lot of mass, like Pluto and Neptune, the outcome isn't just a big bang. It's a fundamental change in balance. Pluto may be small. It only measures about 1/6 the length of Earth, but colliding with Neptune, our fourth largest planet, would be like a pebble striking a bowling ball. Except that pebble is made of rock and ice, traveling at thousands of kilometers per hour. The impact would likely destroy Pluto's core. Its icy crust and rocky center would be shattered, sending fragments flying through space. Some of it might get pulled into Neptune's atmosphere, burning up or adding to its already mysterious stormy layers. Other fragments could become new moons, orbiting or drifting around Neptune freely as a trail of cosmic shrapnel.